Hello students, welcome in your quantum mechanics class. In this lecture we will discuss about particle in a box. So we consider that a free particle of mass m is confined to move in one dimensional rectangular box of length L. We consider this is a box, its length is L. We consider along this axis, this x axis, and this is origin, x is equal to 0, x is equal to L. So this is the length L of the box. So particle is free to move in this box. So we suppose that particle move along the x axis, so that is motion is one dimensional. Now consider the balls of the box be rigid. Balls of the box be rigid, elastic and non-penetrable. So consider the particle move along the x axis between x is equal to 0 to x is equal to L. So particle is somewhere moving in this box whose mass is m. It moves back and forth. So we will discuss how it moves from both the classical aspect and from both the quantum mechanical aspect. Now consider the collision of the particle with the balls be elastic, so that there is no loss in the energy. Let us present this by an infinite square well potential. So this is x is equal to 0, x is equal to L. So as the walls of the box are rigid and the collision is inelastic and the balls are non-penetrable, so we consider that at x equal to 0 and x is equal to L, the potential is infinite, and within the box potential is 0 as we consider a free particle of mass m. Free particle means there is no force. If there is no force, no potential, so V is equal to 0 inside the wall. So x equal to 0 to x equal to L, potential is 0, and for x is less than 0 and x is greater than L, potential is infinite. So the another name is of this article is particle in one dimensional by one dimensional, because the particle moves along the x axis and one dimensional infinite potential well. Infinite potential well because at the boundaries potential is infinite and it is like a well. So that's why we call it one dimensional infinite potential well. Now another name, or in the examination from another aspect, the examiner can ask a question: V is equal to 0 for x is less than 0 and for 0 is less than x is less than L. So x lies between 0 to L, V is equal to 0, and V is infinite for x is less than 0 and x is greater than L. So we define V is infinite, x is less than 0 and x is greater than L. V is infinite outside the box and at the boundaries, and V is equal to 0 inside. So that's why 0 is less than x is less than L, that means x lies between 0 and L. So this is another way to ask this article in the examination from 3 with the help of 3 names: particle in a box, particle in one dimensional infinite potential well, or from V is equal to 0 to infinite for these conditions. So now first we consider the classical view. As in classical mechanics, we know that particle can have any value of energy because it is in continuum. If the energy E is equal to 0, that means particle is at rest. And if E is greater than 0, if energy is greater than 0, that means particle will move along the axis, that means x equal to 0 to x equal to L, and it will experience a force F is equal to minus dV upon dx. You know how we write F equal to minus dV upon dx in your first year classical mechanics class. So F equal to minus dV upon dx, that means at the boundaries it will experience a force due to gradient in potential. So that means it goes back and forth in the box, because at the boundaries V is infinite. If V is infinite, force is infinite. So that means in the direction opposite to the motion of the particle, it is reflected from the balls and moves back and forth in the well or in the box from your classical view. Now we will talk about the quantum mechanical view. Quantum mechanically, we know the Schrodinger wave equation d square psi upon dx square plus 2m upon h cut square E minus V into psi is equal to 0. Let it be equation number 1. So this is Schrodinger wave equation for one dimensional motion. So for a free particle inside the well, we know V is equal to 0. So we will substitute V is equal to 0. So this equation can be written as d square psi upon dx square plus 2m upon h cut square. V is 0, E into psi is equal to 0. So let it be equation number 2. Now d square psi upon dx square plus k square into psi is equal to 0. What is k square? K square is 2me upon h cut square. So this is, let us suppose, a constant k square. So we will find out what is k. Now what is this? This is like a mathematical second order differential equation, d square by upon dx square plus k square y is equal to 0. You know, in the mathematics, instead of y here is psi. What is psi? Psi is the wave function of the particle. In this article we will find out the wave function and the energy of the particle with the help of the boundary conditions. So now the solution of this equation, let it be equation number 3. The solution of this equation is psi equal to a exponential iota kx plus b exponential minus iota kx. So it's better if we write it psi x, because it is a function of x only. Okay, psi x. Let it be equation number 4. Now we will find out the constants a and b with the help of boundary conditions. Now what are the boundary conditions? In simple language, the conditions at the boundary. So what is the condition at the boundary? V is equal to infinite and at x equal to 0. So the particle returns back at the boundary. So if particle returns back, psi is equal to 0 at x equal to 0 and x is equal to L. This is the boundary condition. That means the wave function of the particle is 0, because particle cannot penetrate in the wall, particle cannot leave the well. So at the boundary it will reflect back. So here there are two components. This is iota kx along the x-axis, this is minus iota kx. So this is along the x-axis but in negative direction. So psi is equal to 0 at x equal to 0 and x equal to L. So first we substitute at x equal to 0, psi equal to 0. So question 4 becomes a exponential iota k into 0 plus b exponential minus iota k into 0. I have substituted the value of psi and x, so it will be a is equal to minus b. So from the boundary condition psi equal to 0 at x equal to L, we find out that a is equal to minus b or b is equal to minus a. So the equation 4 can be rewritten as psi x is equal to a exponential iota kx minus a exponential minus iota kx. I substitute minus b as a in equation number 4. So it's better to write it as a exponential iota kx minus exponential minus iota kx. This is like exponential iota theta minus exponential minus iota theta. So I will multiply it with 2 iota and divide it by 2 iota. Now this is 2 iota a sine kx. This is sine theta, where theta is kx. So let 2 iota a be another constant, c sine kx. So this is psi x from the boundary condition as psi is equal to 0. Now at x is equal to L, psi is again 0 because particle cannot penetrate in this wall, particle cannot leave. So at x is equal to infinite, wave function psi is equal to 0. So it should be continuous, so that's why psi is equal to 0 at x equal to L. So question 4 becomes a exponential iota kl, it is equation number 5. So equation 5 becomes c sine k x is L. I have substituted the value of x equal to L and psi is equal to 0 in equation 5. So c is a constant, therefore sine kl is equal to 0. So sine kl, that means sine theta is 0. Sine theta is 0 only if theta is equal to n pi. N is 0, 1, 2, 3. So where theta is kl equal to n pi, so n is 0, 1, 2 and so on. So if n is 0, it is 0. So sine 0 is 0. If n is 1, it is pi. So sine pi is again 0. If n is equal to 2, then it is sine 2 pi. Sine 2 pi is again 0. So but is k, it is n pi upon L, and we know k is 2me upon h cut square under root is equal to n pi upon L. On squaring both sides, we will get 2me upon h cut square is equal to n square pi square upon L square. So from here E is equal to n square pi square h cut square upon 2ml square. So this is, let it be equation number 6. So what is this E? E is the energy of the particle. So E is n square pi square h cut square upon 2ml square. So that means, what is n? N is the quantum numbers. E depends on n. So let us denote the energy of the particle by En, because it is a function of n if n is equal to 0, 1, 2 and so on. Now En is, from equation 6, En is equal to, I am rewriting it as n square pi square h cut square upon 2ml square, and so En is directly proportional to n square. So E is not equal to 0, because if E is equal to 0, then quantum mechanically it is not possible, particle is not at rest. Now that means E, we consider n is equal to 1, 2, 3 and so on. So for n equal to 1, I will write as E1 is directly proportional to 1 square, that is 1. So E1 is equal to pi square h cut square upon 2 ml square, and for n is equal to 2, its E2 equal to 2 square pi square h cut square upon 2 ml square. So what is this pi square h cut square upon 2 ml square? This is E1. That means E1 is equal to E2 is equal to 4 E1. Similarly, if I go for E3, so it is 9 E1, and similarly E4 is equal to 16 E1. So here you can conclude that the energy of a particle in one-dimensional infinite potential well or in a box is not in continuum. The values of energy are discrete, and as the energy level increases En, the energy is directly proportional to n square. That means for the first level, if energy is E1, for the second level it is 4 times of the first level, and in the third level it is 9 times of the first level, and in fourth level it is 16 times the energy of first level, that means E1. So and so on. So thus we find out that particle can have any value given by E1 or 4 times E1 or 9 times E1 or 60 times E1, hence the energy is quantized. But classically energy is in continuum, but quantum mechanically we find out that energy is quantized. These allowed values of energy of the particle are called energy levels or eigenvalues of the energies, and we can show these as like this is E1, energy level E1, and this is E2, energy level E2, and so on E3. So what is this E1? This E1 is E1, E2 is 4 times E1, and E3 is 9 times E1. So and so on we can represent like this. Now it clearly indicates that energy levels are not equally spaced. So as we move higher in the energy levels, the separation between the energy levels increases. So this is corresponding to E1 is corresponding to n is equal to 1, this is corresponding to n is equal to 2, this is corresponding to n is equal to 3. Now we will find out the momentum value or the eigenvalue of momentum. Now we know the linear momentum of one of the allowed value En given by P is equal to 2 MEN, because energy is a function of n, so Pn. So how I write is E is equal to half mv square. If you know in your classical mechanics, quantum mechanically, we are interested in P square upon 2m, but I had multiplied by m and divided by m. So it is m square v square, m into v is momentum, so P square upon 2m. So E from here P is equal to 2me. Now E is a function of n, therefore P is a function of n also, so I write Pn equal to 2men. Now what is En? En is n square pi square h cut square upon 2ml square. 2m, this En is n square pi square h cut square upon 2ml square. So finally we have n square pi square h cut square upon L square is the momentum Pn. So it is a function of n also. So thus momentum is also quantized as energy is quantized in expression 6. Similarly in expression 7 momentum is also quantized. Now Pn is a function of n, and it is directly proportional to the quantum number n. It is directly proportional to the quantum number n because it is p square. It is p square. This is from here. Pn is directly proportional to n. First thing, it is directly proportional to quantum number. Second thing, it is inversely proportional to L. So Pn is inversely proportional to L, but is L is the length of the well or the box. And third, it is independent of the mass because there is no term like m in this expression, but energy of the particle is a function of mass. So this is all about the eigenvalue of the momentum. Now you have noted that I define n equal to 0, 1, 2, 3 and so on, but while substituting the values I skip n equal to 0, I substitute n equal to 1 and corresponding to that I write E1. That means I started for n equal to 1. So now this will be discussed here. The important thing is 0 point energy. So 0 point energy is the minimum possible energy possessed by the particle inside the box is called 0 point energy. So 0 point energy is E1 is equal to pi square h cut square upon 2 ml square. This is generally asked in your competitive exams. So since E is equal to 0 not allowed, that's why I have not substituted n equal to 0 and I have not written E0. Is not allowed because if E is equal to 0, then psi is also 0, because when we start the derivation we write d square psi upon dx square plus 2m upon h cut square E minus V into psi equal to 0, and in this article we know V is equal to 0 inside the well, so we have expression d square psi upon dx square plus 2m upon h cut square into E into psi equal to 0, and if we substitute E equal to 0 in this expression, then d square psi upon dx square equal to 0, that means psi is equal to 0. If wave function is 0, then what is the meaning? That everywhere inside the box the probability of finding the particle is 0. That means psi square is 0 if psi is 0. And if there is no particle in the box, then what is the thing about which we are talking about? Okay. So this is not a possible case. So n equal to 0 is not allowed in particle in a box problem. So hence the particle cannot have 0 total energy inside the box, so it cannot be at rest in the box quantum mechanically. So this is important thing. So 0 point energy is not 0, 0 point energy is pi square h cut square upon 2 ml square corresponding to n equal to 1. N equal to 0 is not allowed, it is not possible quantum mechanically. Now we will find out the wave function. We know that from equation 6 psi x is equal to c sine kx. This was equation number 5. I have read it again. So we know k is n pi upon L. So I will substitute the value of k. So it will be psi x is equal to c sine n pi x upon L. This is equation number 6 or 7. This is 7. This is now psi x. Now we know the probability density. You can go through the lecture on probability density. P is psi star x into psi x. Here x is nothing, just psi is a function of x. This represents. So we know psi is c sine n pi x upon L into c sine n pi x upon L. Star represents the complex conjugate of psi. So it will be c square sine square n pi x upon L. Let it be equation number 8. So this is the probability density. Now we know the probability density between x is equal to 0 and x is equal to L is 1. That means probability of finding the particle within the well is 1. That means particle exists inside the well. So this is normalization condition. You can go through the lecture on normalization condition. So normalization condition is 0 to L psi star psi into dx is equal to 1. Why it is dx? Because particle is moving along the x-axis, we consider the case of one dimension, so x equal to 0 to x equal to L. So we have psi star psi dx is equal to 1. This is the normalization. Now we will substitute psi star psi. Psi star psi is c square is constant 0 to L sine square n pi x upon L into dx is equal to 1. So let it be question number 1. Let it 9, let it be 10. Now we will solve this integral. Now sine square theta, so we will write it as c square 0 to L 1 minus cos 2 n pi x upon L upon 2 into dx is equal to 1. Now we will integrate it as c square 0 to L upon 2 1 into dx minus c upon 2 integral 0 to L cos 2 n pi x upon L upon 2 is already here into dx is equal to 1. Now in the first term we have c square upon 2 into derivative of this, integration of this is dx is x, so from the limit 0 to L, and the integral is standard integral is 0 is equal to 1. So this is a standard integral. You can go through the standard integrals. So what is this now? From the limit we have c square upon 2 L is equal to 1. So finally c square equal to 2 upon L. So c equal to square root 2 upon L. Now we have find out the unknown constant c. So as we know what is c, c is square root 2 upon L. So the expression 7 can be rewritten as psi x is equal to, now what is the value of c? It is square root 2 by L sine n pi x upon L. So this is the wave function of the particle in one dimensional box. This is square root 2 upon L sine n pi x upon L. That means if we go for the wave function of particle corresponding to n equal to 1, corresponding to n equal to 1 energy value is E1, and wave function is psi 1 equal to square root 2 by L sine pi x by L, and corresponding to it is psi 2, it is 2 by L sine 2 pi x by L. I am substituting the value of n equal to 1, n equal to 2 and n equal to 3. So we have the wave function. Now the normalized wave function psi 1, psi 2 and psi 3 can be plotted. If we plot, then we know this psi 1 is corresponding to E1, n equal to 1. Now psi 1 is square root 2 upon L sine n pi x upon L. So at x is equal to 0, sine pi x upon L is 0, sine 0 is 0, that means psi 1 is 0. So that means at x equal to 0, wave function is 0. Here we are plotting psi 1. Okay. At x equal to L, at x equal to L, it is sine pi because L is cancelled with L. So sine pi is 0, so psi 1 is again 0. So it is 0. Now we consider in the middle. In the middle it is L by 2, x equal to L by 2. If x equal to L by 2, in this expression it will be psi 1 equal to square root 2 by L sine pi x is L by 2L. So it will be square root 2 by L sine, this is pi by 2. So sine pi by 2 is 1. So that means psi 1 is square root 2 by L. That means there is some value. So let it be square root 2 by L, this height. Okay. Now In the middle of this L by 2 and x equal to 0, there is L by 4. If it is L by 4, then psi 1 is square root 2 by L sine pi L by 4L. So it is square root 2 by L sine pi by 4. And if we talk about psi 1 at x equal to between L by 2 and x equal to L, so it is L 3L by 4. So at 3L by 4, psi 1 will be square root 2 by L sine 3 pi by 4. And now you can see what is the behavior of this psi 1. Psi 1 at x equal to 0 and x equal to L, it is 0, then it approaches to, it increases to pi by 4, pi by 2, and then 3 by 4 and then pi. That means the behavior of this wave function is sinusoidal like. So this is like this. So this is psi. Now if we multiply psi 1 at each value of x equal to 0 to x equal to n for any value of x, we multiply psi 1 with its complex conjugate, then there will be the probability density. So that is psi 1 star into psi 1. So we can also plot that. Similarly, for n equal to 2, you can plot psi 2. I hope you will find out the psi 2, and this is the assignment for you to find out psi 2 and plot it in the diagram, and psi 3 and plot it in the diagram. If you have any problem, you can discuss with me. I will try to solve it. So this is all about the particle in a box. Thus particle in the lowest energy level at n equal to 1 is mostly likely to be in the middle of the box, while the particle in the next higher state is never there. You can find out when you find out psi 2, and classical physics of course suggests that same probability of particle being anywhere in the box. So this is the difference between the classical view and the quantum mechanical view. I am repeating again, classically the particle have any value of energy as we consider the boundaries of the well are rigid, elastic and non-penetrable. So it is like a ball in your room, and if you throw it on the wall and it is bounced back. So it is like this. So it is reflected from the boundaries, and as there is no energy loss in your example of your room and wall, in that case there is loss of energy when ball collides with the boundaries, but in this case we assume that there is no loss of energy. So the particle will move back and forth inside the box, and it has any value of energy between 0 to any value. So the energy values are in continuum, you know, in your classical physics. So but quantum mechanically, when we started with the help of the Schrodinger wave equation for a free particle, we find out that the energy values are not in continuum, they are discrete like E1, E2, E3. That means energy is quantized. On the basis of that, we have different energy levels. So particle cannot exist between the levels. So particle will exist either at E1, at E2, at E3, depend upon its energy. So its energy is corresponding to these level. N equal to 1 is E1, N equal to 2 is E3, and N equal to 3 is E3, and at N equal to 2 it is E2. So that means, and we find out that as we move from n equal to 1 to 3, the spacing between the energy level increases. So there is the gap between the energy level is not equal, and this is all about the quantization. So that means energy levels are quantized. Now when we find out the wave function of the particle, you can see that this is the wave function of the particle corresponding to n equal to 1 and corresponding to which energy level, energy is E1. So the wave function is psi 1, and you can find out psi 2, you can find out psi 3, and I request you to find out, try to find out psi 2 and psi 3, and if you have any problem, discuss with me. And this is all about particle in a box. It is important article from both your exam point of view and from your conceptual point of view, and if you go through any entrance exam. So this is very important. What is the wave function and what is the energy value and 0-point energy for a particle in a box or particle in one-dimensional infinite potential well. Thank you for watching.